Welcome to everyone. Myself Padala Rajshekar, Assistant Professor, Department of Civil Engineering, SR University, Warangal. Today's topic is hydrology. So, why we have to learn about hydrology and what we can get some knowledge regarding hydrology, we will discuss in this upcoming slides. So, first of all, basic introduction for hydrology. So, before going into hydrology, I would like to explain first what is hydro and what is logy. So, first of all, hydro and logy, that means hydrology. So the word hydro refers to water and logy refers to science, that means the study of water. So everything related to water, the study of water. So that's what it is. Very water is very vital for all living organisms on earth. So whatever the living organisms on earth, they depends on water. So water is very important. If there is no water, and if there is no water, for example, there is no life. So that is fact. So in this particular hydrology, first of all we have to understand the source of water, where we will get water and how we can utilize, and how we can make product from that. Like if we can take example, best example, agriculture. So if we have some kind of certain water at that particular location, so we will get the outcome of agriculture product. So the thing, this is not new or any new invention which recently introduced or like kind of thing. It is very old. Like for centuries people have been investigating where water comes from and where it goes. As I told, uh, the source is the source is rainfall. So here they are clearly mentioning people have been investigating where water comes from and where it goes. That means the in whatever the amount of water, for example, there will we call it as rivers. For example, we can take in Indian conditions Ganga, Godavari, Krishna, Kaveri, these things. So there usually we can see in our newspapers like the entire India, like southwest monsoons, floods, some kind of news we can see. That means particular floods will happen to particular basins like Godavari, Krishna, Ganga, like that. So water is coming, the only source is that rainfall, and how we have to manage it. That's what we have to understand, the pattern of the rainfall, and we have to keep on analyzing for needs. Why some of it is salty and some is fresh? So we have to understand basically how much percentage of water is salt in like ocean, and how much is fresh in terms of ice cubes, in terms of groundwater, and in terms of surface water. Why sometimes there is not enough, and sometimes too much? So that is called, sometimes not enough means it comes under drought conditions, sometimes too much is comes under flood conditions. All questions or answer related to water have been grouped together into discipline. So these all circumstances together, we will get the idea of what is happening. And as I mentioned, hydro means water, logy means like it's a kind of science. Logy means the study of water. So coming to the next slide, basic hydrology. As I mentioned, first it is a study of science. It is a science of water. So completely it is depending on the water. And here another like in a kind of definition, I can tell it is a science that deals with the occurrence, circulation, distribution of water of the earth and its means Earth's atmosphere. That means whatever, for an instant, the rainfall is happening at particular location, that is how it happens. And after losses in the terms like evaporation, transpiration, ground intake. After losses, and what are the rest amount of the surface water is filling the ponds and everything, and our remaining water will go to ocean. That is the circulation. And coming to the circulation means after that leftover water is going back to the again to the atmosphere, like through vapor. Through vapor it will go, again it will come back. It's called it's a cyclic process. There won't be any kind of never end process. And It's like in another terms, if we want to discuss, a good understanding of the hydrological process is important for the assessment of water resources, their management and conservation of global regional scales. So till now we discussed what is hydrology. Hydrology means water. Water means the main source is rainfall. After rainfall, ponds, lakes will be filled and rest over is going to again to the atmosphere. So now to understand this everything, the concept of the hydrological, to understand this is called hydrological process. Hydrological process, what is the process is beyond this, to manage the water and to make sustainable way. So that is very important. Sustainable way means, sustainable is nothing but to ensure future needs. That means we have to see today and we have to safeguard for future generation. And coming to the basic terms of water exist on the earth in all, like how many kinds it will exist, mean three kinds. One is in terms of liquid, that everyone is able to see this image, like rivers, ponds, lakes comes under that, we can see. And next one is solid in the terms of ice cubes. We can know the very famous in terms of India is called Himalayan and Antarctica, like that. And third one is gaseous and in various degrees of motion. Like I mentioned that whatever the rainfall is happening, and after that it will go back to the atmosphere. This going back through evaporation. So that is comes under gaseous. And in terms of general, in general sense, engineering hydrology deals with, like for now we are basically in engineering field. So we should understand, after understanding this cyclic process and what we can do from this. So what are the things we need and what are the things we have to do to make sure that for future generation, a sustainable way. So first one is estimation of water resources, and next one the study of process, as I mentioned, such as precipitation, evapotranspiration, runoff and their interactions. This will be discussed in depth in upcoming videos and upcoming slides. So precipitation is nothing but rainfall, and evapotranspiration is nothing but the water is going back to the atmosphere, and runoff is nothing but the water, whatever the after rainfall, the excess water flowing on that particular surface is called runoff, and their interactions. And coming to the another point, third point, the study of problems such as. So if we understand the overall view of what is the amount of rainfall, what is the losses in terms of evapotranspiration, and what is the runoff and their interaction, then we can go easily with respect to making the analysis of floods, like droughts. This floods and droughts we can understand and we can mitigate and we can solve the problems of water related issues. So still now I told hydrology, precipitation and these things. Now I want to give a like in an image way to understand in a simple way. For example, if you are treating this as a surface, this we know the surface, this is pond, this is surface, like we can see here plants are there, and here some kind of mountain ranges, and we can see here snow. So this is what we can see in our daily life. This is the exact image. So now coming to the hydrological cycle, the how hydrology works means, for example, first we have, there is no starting point and end point, but I am taking here is in to understand for your reference, precipitation. So if you are taking precipitation, that is precipitation means rainfall. So precipitation means rainfall. So certain amount of rainfall receiving from clouds to particular surface. After losses means after taking the ground recharge, and after going with respect to ponds, lakes and everything, the remaining water which is flowing on that surface is called surface runoff. So now everything came. Now rainfall, we can see the precipitation, and we can see the runoff, we can see That means runoff means after a kind of lakes and ponds. And we can see what is the next thing in this process. Now we have completed up to here, right? Now this process we have to see. Now this process comes under like next one, evaporation. Evaporation, transpiration, sometimes we call like evapotranspiration. Evaporation means the water which is escaping from land surface to atmosphere with respect to some kind of ponds, lakes, or any kind of water bodies. The water is escaping from that particular place to atmosphere is called evaporation. And transpiration means the water which is escaping from plants, that is called, and escaping from plants to atmosphere is called transpiration. So these two things which again will take back to atmosphere, and there the process is called condensation. Condensation means, as we know that condensation means evaporation like converts to condensation, then after condensation we will get again back to rainfall. So this is a process, never end process, and that's what we can tell in many we can able to listen the things that water we cannot create or we cannot destroy the things. This is a process, this is a cyclic process where we are seeing that the rainfall and runoff after losses, and the things transpiration and evaporation after condensation and precipitation. So this is the cycle, hydrological cycle. And this hydrological cycle, if we are able to understand, then we can do the management. Like for an instant, the management comes under here. See how much amount of rainfall is happening. If we come to know, then what is the surface runoff after losses like evapotranspiration or groundwater recharge, or else you can take ponds, lakes after filling. And this is very important, surface runoff, to understand how much water is available on that particular area. Area means, in the terms in our hydrology, we have to tell area means watershed. Watershed is nothing but a river. River means in Indian conditions we can tell like Ganga, Godavari, Krishna, Brahmaputra, like kind of things. And if you are going like Nile river, like kind of things, whatever the river, we call it as watershed. That means the river which is occupying certain area and making a single outlet. That means single outlet means the entire water, for an instant you can take Ganga river, the entire water will go to ocean point. So that last point is called outlet point. That I will clear the things in upcoming videos, no issues. So now I hope here you people can understand what is hydrological cycle, and why we have to understand for, and how we can go with respect to management strategies. So the simple sense, if I want to wind up this hydrological cycle, I can tell in a simple words that if we know the surface runoff on particular watershed, then we can go with management techniques. Management techniques means we can store water for certain places to make sure for future generation. That is what we call it as sustainable way. So the thing next one, now we are a little aware of hydrological cycle, as I shown before. What is hydrological cycle? So now in a simple sense, if I want to conclude, as I told, whatever we are saying that comes under the hydrological cycle, like earth. So hydrological cycle has important influence in variety of fields: agriculture, forest. So agriculture, forest, geography, economics, socio-economics, political scene. That means, for an instant, if I want to go for previous slide, for an instant, this entire area is dominated with respect to forest area on the ground. For example, that means agricultural forest area. For example, if you want to understand more clear, forest area, if entire area on the land is completely with respect to the forest area, then the runoff means the excess water which is flowing on the particular surface is called runoff after losses. So if we have completely with respect to forest area, there will be less runoff when compared to barren land. Like, so if forest is more, the capacity, water holding capacity of that particular region will be more, like plants will hold the water. So that means whatever, if area is covered, completely covered with forest, so runoff will be less. If area is completely with barren land, the runoff will be more. In a simple sense, if there is a like a flat, like a completely concrete, for example, the surface is rough like concrete, you can imagine. If we are able to if any rainfall happened, for example, in that particular area, such that the there won't be any kind of intake of water. Like it's a completely concrete, like road, you can take it as a road. Whenever the rainfall is happened on that particular road, it won't take water. That means it cannot do infiltrate, because the surface is completely hard. Like hard means it cannot take it anymore. So if the surface is covered with respect to forest, it will take, because of the plants, it will absorb. So the scenario is like that. If a particular place is having kind of forest, the analysis is different, and the surface is having more dominated by built up area, is nothing but whatever the residential buildings, commercial buildings, industrial buildings, the development activities what humans are done. So there, if it is there, then it comes under another kind of analysis. So like what is the change happened from last 2 decades, like 20 years, when there is a drastic increment in built up area, then how it is affecting our runoff, and then how we can make sure that for future generation. So it's a different field and different topic. Like it's a kind of analysis, it's very hard. That's what here importantly, hydrological cycle has important influence in a variety of fields. Like agriculture, if agriculture is dominated, what is the influence on the water storage and sustainable way? If forest is dominated, if geographical locations or geography and economic, socio-economic ways, political scenes, if any circumstances, any kind of the thing is dominated, what is the thing will happen to that particular management things. So now coming to the engineering applications. Engineering applications of the knowledge are found in the design and operations. As I mentioned, we have, if there is an excess amount of runoff is happening, we have to store it. So what kind of the design is suitable for particular location? Everywhere we can't construct large dams, because financially we have to see the problems from all perspectives and the things when we are going with the development activities. Projects dealing with like a kind of water supply, if that particular place is suitable for only water supply, or with respect to water supply and hydropower, we can generate it, but particular location hydropower or irrigation and drainage, flood control, or navigation or coastal works, or various hydraulic structures, salinity control, and recreation use of water. So these all things under comes under engineering application. So each perspective, each one application will be there. So now up to here we understood what is hydrological cycle, how it works, and what are the things affecting, like how if forest is more, if barren land is more, if agriculture, then how we can manage the water. These are the real time problems which we are seeing. That's what, as I mentioned in the introduction itself, the thing, this is not new. The problem with respect to water is not new, and this was an old one. Like old means it's an every time it will be there, the problem with respect to solving this solution according to the keep on increase in the things, like drastic urbanization, we can tell. So now coming to the, actually before understanding some things, we have to understand actually what is the amount of water is available in terms of world, like earth. So we can make that around 97.5% of the water available on the earth is salt water. that means oceans. So majority of the whatever, for example, we have 100 percentage of the water on earth, so 97.5 percentage of water is salt water. So entire world population need to depend on rest 2.5 percentage of water. We can now desalination techniques are coming in terms of making this, but they are like cost is more. Now coming to the another thing, 2.5 percentage of the water which is available for like we not available, we can tell, I can tell it as fresh water, but only a small fraction is readily accessible. Why? So as I mentioned, in 197.5 percentage is salt water, rest 2.5 we can use, I told. But the thing is that that is only with respect to fresh water, not readily available. That means I went with another further classification, like you can understand here. So in that particular 2.5 percentage, if we consider as 100 percentage, so 2.5 percentage you consider as 100, in that 74 percentage of water, 74 percentage of water, that means everything comes under this fresh water only. So 74 percentage is trapped in glaciers and ice caps. So you people knows that ice caps like Antarctica, Himalaya, this kind of the things we can see like Greenland, ice glacier. So in that 2.5 percentage, if you consider 174 percentage is trapped as glaciers and ice. So the rest in that particularly 25.6 percentage which is stored in ground. That's what we can see. The majority of the agriculture is depending on groundwater. So 25.6 percentage of the water is on ground. And next coming the rest 0.4. So you can understand 0.4 percentage is surface fresh water. Surface fresh water means rivers, lakes, wetlands. So they comes under rivers, lakes, wetlands. So now you can understand, in 100 percentage if you take on the earth, 97.5 percentage goes to salt water, rest 2.5. In that 2.5 if you make consider as 100%, 0.4 percentage is only the fresh water which is available on rivers, lakes and wetlands. That's what we have to do analysis with respect to rivers, lakes, ponds, wetlands, and we have to store it, and we have to do the things for future generations. So this is what I have taken the reference from source Barbara. So this you can see, if you consider 100 percentage, in that particular percentage 97.5 percentage is sea water, and the fresh water is 2.5, and again that would divide the ice caps, glaciers, groundwater, lakes, rivers, soil moisture, and everything will comes under only 4.4 percentage, which we can able to in terms of lakes, rivers and the things. Now coming to the other way, below land surface soil porous contains both air and water. Region is called as Vadose zone or zone of aeration. There will be land, and below that air will be there and water will be there. That zone is called zone of aeration. Now we are entering into little more in depth to understand the scenario of the land, like watershed. So water stored in Vadose is called as soil moisture. So the soil moisture is drawn into roots of growing plants. So plants can they can draw through roots. So water is transferred from plants as vapor to the atmosphere. As I mentioned, in hydrological cycle, there will be transpiration, there will be evaporation. Evaporation will comes under the water which is escaped through like it's a kind of ponds, lakes and rivers. In terms of plants, it comes under transpiration. So under certain condition, water can flow laterally in the Vadose. We call it as interflow, and water vapor in the Vadose can also be migrate to the land through the land surface and evaporates. excess soil moisture is pulled down by gravity, so that we call it as gravity drainage. So now some kind of things we have to understand, some basic terminologies to go further slides and further videos. So first of all, we should understand what is precipitation and depression storage, overland flow and infiltration. So coming to here, when atmospheric conditions are suitable, water vapor condenses and forms droplets. These droplets may fall to the sea or onto land, that is precipitation, or may operate while still aloft. So after this, these things, some temporary storage on the land as ice, snow or water puddles, they are called as a depression storage. This, and in some will drain across land to the streams, that is called overland flow, that is called in terms of normal thing, surface flow. So if surface soil is porous, some water will deep into the ground by a porous called infiltration. As I mentioned, after losses, when I told there will be rainfall, there will be runoff with respect to after meeting the losses comes under filling the ponds, lakes and wetlands or anything, and after the infiltration. So ultimate source of the recharge to ground, that means groundwater. So now we understood the scenario of the ground, scenario of the ground and top scenario of the particular watershed. So top of saturated zone is called water table. So water stored in the saturated zone is called groundwater. So water moves through the rock and soil layers until it discharges a springs or it seeps into the ponds, lakes and streams. So groundwater contribution to the stream is base flow, and water stored on the surface of the earth in terms of water can be stored in terms of earth is called ponds, lakes is called surface water, and precipitation intercepted by as I mentioned, water escaped from like water bodies is called evaporation, and plants transpiration, both we call evapotranspiration. And coming to the groundwater components in the hydrological cycle, Vadose zone. Vadose zone is called just now we discussed about some zones. So Vadose zone is called unsaturated zone, phreatic zone is called saturated zone, and intermediate zone separates the phreatic zone from soil layer. So now you people can understand little about hydrology and why we have to study and how and what is the things. Now slowly we are entering into the terminologies. So as I mentioned, rainfall means if you are considering a rainfall, then after losses in the terms infiltration, after infiltration it will go to like groundwater recharge, and the groundwater recharge. So two kinds of rainfalls will be there, snow or rainfall, that depending on the climatic conditions and that region. So first rainfall, after ponds, lakes filling the things, infiltration, groundwater recharge, and rest amount is called surface runoff. Surface runoff and the ground runoff also will be there, as I mentioned previous slide. So this two is meeting, that is called runoff, and evaporation means completely from water bodies. So evaporation is completely from water bodies, and as I mentioned, transpiration from with respect to plants. So evapotranspiration comes under both plants and water, and again it will go back to see the rainfall is coming, and it is going with respect to the runoff, again it is going back, and there will be condensation, and again it will be coming back. So to understand this thing, we have to know the basic knowledge of this hydrological cycle. This is very, very most important. And coming to the point, we have to understand the next thing, we have to understand what is on the surface, whether forest, agriculture and this kind of things, and how it will take. So now coming to the little more in depth we are going. Now coming to the another thing is that hydrological equation. So hydrological cycle is a network of inflow and outflow. For an instant, there is a watershed. Watershed means river. So there is a watershed, there is some amount of rainfall is happened, some losses in the terms as I mentioned previously, like losses means infiltration, ponds, lakes, this all filling the things, and the thing like these things all comes under the rainfall is happening, losses, then runoff. Then what is the change in the particular watershed? So they were mentioned in many ways. Equation 1 represent there will be input output change. For example, there is a input, like there is a amount of rainfall, and there is a output, that is a excess runoff is going, and what is the change in the particular watershed. That means how much there will be increment in the groundwater, or what are the things, like ponds, lakes are filled or not. The kind of things we can do analysis. Is a conservation statement that all water is accounted for. That is, we can neither gain nor lose water. So that's the thing. For an instant, if the particular area is forest area, there will be increment in groundwater. If the particular area is completely urban area, then there won't be any kind of improvement in terms of groundwater. So change in storage means depending on the particular aspects or particular things are going on that particular surface of the watershed, this will change. So if you are maintaining the watershed in a way to promote, to promote means in the terms to store, such that the area, whatever we are seeing the area, it will be very good to future generation. If we are making completely with respect to constructions, human activities or more, such that the storage capacity of that particular basin will go down, and it will make some issues. Like issues means decline in the groundwater will affect agriculture productivity, and decline in the groundwater will affect domestic use, and decline in the groundwater will affect industrial use. So this kind of things, they need to suffer. So we have to protect. That's what many we can see, the plantation programs are going on in overall India or worldwide. They will plant more, they are planting more, the awareness camps are coming more. That means if you plant, it will hold the water. That's only, in a simple way. So some people, some kind of things on a global scale, they have given some terminologies like atmosphere gains moisture from ocean and land is called E, and precipitation is P, evaporation is called E, QI is called overland flow, infiltration is called F. Some standard things they were like every time. For example, precipitation means you can't write R, so it should be E. Evaporation means you have to write E. Infiltration means you have to write F, not I. So some standard terminologies they were mentioned. So that's what everyone is following. Now coming to the some scenarios, the groundwater reservoir may receive water, that is QI, and releases water, that is Q naught. That means input output equal to change in the storage. Now you understood. So now coming to the some kind of streams, like stream means river, receives water from groundwater. As I mentioned previously, there will be runoff with respect to surface and groundwater. Previously I have shown the figure, you can refer that. So now here the streams receives water, the streams receives water from ground aquifer by base flow, or termed as effluent. That means gaining figure. The runoff, we always that there will be a stream, and some runoff there will be from ground. If something is contributing to the surface, that is called something, it is gaining. The river is gaining some water from ground also, so gaining stream. For an instant, stream losing water from ground are called influent. That means losing streams. So both are very important terminologies in our hydrology. Gaining stream, losing stream. There will be another terminologies we call effluent and influent. Effluent means it is getting something water from ground. Influent means it is losing. So now you are clear, right, up to here? If any comments you can make. A basin scale hydrology subsystem is connected to the global scale through P or not equation. So some kind of further they were generated. P means rainfall, E means evaporation, T means we can see T, and RO is runoff, and delta S is storage. So we can make it as ET also, evapotranspiration, no issues. Delta S is the lumped change in the all sub. That means the change delta S is nothing but change. So they were given in a different things. Equation 2 may be expanded or abbreviated depending on what part of the cycle we are interested. This is important. For example, the groundwater component is equation. Then you can bring Q naught, Qi, this kind of things. Now over long periods of time, the provided basin. Now we can go with another kind of the equation. There are two kinds. If the pumping, if you are included the pumping from the ground, then the new abbreviation comes, that is QPI. That is QPI is nothing but added withdrawal. Now overview of these things. Water budget equation. Water budget equations, previously I have mentioned watershed area. So the area of land drains into a stream or water courses at a given location is called catchment area or drainage area or drainage basin or watershed. A catchment area is separated from its neighboring areas by ridge called divide or watershed. To understand this definition, what is watershed, what is the things but water budget equation. Water budget equation is nothing but what is the intake of that particular watershed and what is the outgoing and what is the rest amount that changes. Now to understand a simple logic, I can tell, you can imagine in your area whatever the river name. For example, I can tell Ganga is a river, Godavari, Krishna, Kaveri in Indian conditions. So if you go for abroad conditions, you can tell Nile river. So if you are imagining one river, that is called watershed. For example, this is an river which is named as X. This is a river which is named as X. So this particular river X receives water from its surrounding area. What is that surrounding area? How it is divided? For example, it can be divided with respect to the ridge line. That means you can see the drawing here. I am making the line. I will tell, you can see this is completely a line which you can see. That means this line is formed on the basis of natural boundaries. Natural boundaries in the sense higher elevation to lower elevation. The water travels from higher elevation to lower elevation. That is a fact, right? So water will travel with respect to gravity, like with respect to higher elevation to lower elevation. So if you have two or three continuously rain for rivers, so we call it as different rivers because that entire area is different from what we are thinking. So this river area, this particular river area is formed with respect to the elevation. So this is my river which is called X river. The river name is called, for example, X river, and we call it as X watershed. So here I mentioned X watershed. For example, if some precipitation is happened, so in this watershed, what are the things will be available? As whatever the people are living here, everything is watershed only. We can see the kind of agriculture, we can see the kind of forest, we can see the kind of urbanization, we can see the kind of industries, we can see the kind of flat areas like which is not like barren lands or the kind of things, and we can see the mountain ranges. So this all comes under watershed. That means when we are doing analysis, so we have to be make sure that this entire area we have to understand. If we understand what is on the surface, then it is very important to go the further things. So now you people can able to understand what is watershed. This I given for your reference to understand. The equation is applied in the form of water balance equation. Yes, water balance equation means if we understand what is there on the surface, then we can understand easily the things are going in order to establish the basic hydrological characteristics of the region. Usually watershed is defined as the area that appears on the basis of topography to contribute all the water that passes to given the streams. So now I want to show in a digital way. As I mentioned, there will be many rivers in your area. For example, this is one kind of river and this is one kind of river name. This may be the the river which is a major river. This you can tell the major river. For example, in Indian conditions, you can take Ganga river. Ganga river having Yamuna river. For example, if you are taking this as Yamuna, so Yamuna is a tributary of Ganga, like that. So this is one kind of watershed. This is one kind of watershed, and this is this small area also you can make it as one watershed. And for example, here also you can make it as one watershed. This should not touch actually. This should go like that. And the watershed, now you understood the basic things of watershed, and divide the area from higher elevation to lower elevation. Now you can say here also you can take it as one kind of watershed. So these all things are watershed. Watershed is nothing but the representative of the names which we can see. So now watershed characteristics. So watershed characteristics is nothing but, for example, if it is steep, then the runoff means runoff will be more. If it is not that much steep, then the runoff will be less. That you understood. So now the applications, finally we are coming with applications in the design, operations, or capacity of the storage structures, like such as reservoirs we can control, construct and control, and magnitude of the flood flows in the enable safe disposal, and a minimum flow, and quantifying flow available at the various seasons, the interaction of the flood waves. So this is what some kind of the figures which you can see, like construction of Hoover Dam and the things. So we will meet in the next video for further things we can learn, like hydrological cycle in terms of precipitation, abstractions, and evaporation, like kind of things and analysis. We will meet you. Okay then.